Welcome to this YSL Microsoft Excel tutorial. In this part of the series, we're going to cover the basics of the IFS function. So we'll start the video with a quick recap of basic nested if functions, and then show how you can use an IFS function to create a slightly nicer syntax for that sort of situation. We'll explain how you can set up the IFS function to return a default result, and then we'll show a couple more examples of working with text and dates in your logical tests. So let's get started. To get started, I've created a list of the top 50 highest grossing movies, and as usual, if you want to follow along with the video, I'll drop a link in the description below so that you can download the same sample data and follow along with me if you'd like to. So this video is all about using the IFS function, which basically is a nice replacement for nested if functions. So it probably makes sense to begin the video with a quick recap of a basic nested if, and to do that we're going to create a description for our films based on the Oscar success. I've got three possibilities. If the film didn't receive any Oscar nominations, then it's a not nominated film. If it received at least one nomination but it didn't get any wins, then it's a loser, and for all of the circumstances the film must be a winner. So because I've got three possibilities, I can't get away with just using one single if function. I've got to nest another if function inside the first. So here's what it's going to look like. We've got the basic initial logical test, which is going to check if the Oscar nominations is 0, then it's not nominated. And then we need to open up another if function to check if the Oscar wins is 0, in which case the film can be a loser, otherwise it must be a winner. So let's put that in place. Let's head into the top 50 box office worksheet, head along to column L. I've already got a column header there, and I'm going to say equals if. Then I'll say H2 equals, and then 0. Follow that with a comma, and if that's true, the description is going to be not nominated. Then another comma, and I can open up my second if function, and then my second check is going to be based on cell I2. If that's equal to 0, then the film must be a loser. And then finally, for all of the circumstances, it must be a winner. Now I need to make sure I've closed the correct number of round brackets. I've got two if functions open, so I need to make sure I've got two closed round brackets for the correct number of parentheses. So once I've done that, I can hit enter, and then I can select that cell and double click the autofill handle to fill that formula down the column and get a sensible description for each individual film. So a basic nested if function like the one we've just created works pretty well. It gives us that little bit more power than a single if function by itself, and it's not too tricky to keep track of how many round brackets we've got open and how many parameters we've got to fill in. I think I mentioned in the previous video that in the if function you can nest if functions up to 64 levels. And as you can imagine, the more and more levels of nesting you have, the trickier it becomes to keep track of the round brackets and which position you're in. And it makes it really tricky to fix problems with a complicated formula like that. So rather than using the nested if function, instead we can use the ifs function. Just to show you the basic pattern of the ifs function, here it is. You'll notice that there are no value if false or answer if false parameters. With an ifs function, all you've got is a sequence of logical tests and the answer to return if that logical test is true. If the logical test returns false, then it jumps to the next logical test to evaluate that. Now, in the ifs function, you can have up to 127 different logical tests and possible answers, and no matter how many of these you fill in, there's always only ever one set of round brackets, so it's all contained in one single function. So we can achieve the same results we've just achieved with a nested if using this ifs function, checking if the Oscar nominations is 0, not nominated, otherwise if the Oscar wins is 0, then it's a loser, otherwise it's a winner. The only difference here is that we've got to write an explicit logical test for the value if false part. So the winner, we need to explicitly test if I2, the Oscar wins, is greater than 0. There is no value if false parameter for the ifs function. So let's give that a quick go. I'm going to head back to the original worksheet. Let's just copy across the column header to column M. Then I'm just going to change the name of that one so it's inventively called Oscar Success 2. And then in cell M2 we can say equals ifs. So the first logical test is the same as we had for our nested if example, H2 equals 0. If that's true, then the film was not nominated. Then I can type in a comma and immediately move on to the second logical test. So I don't need to open up any new functions. I can just immediately say I2 equals 0. Follow that with a comma, and if that's true, then the film's a loser. Then another comma, and my third and final logical test, I2 greater than 0. And if that's true, then the film must be a winner. I can then close one single set of round brackets, and then fill that formula down the column and get the exact same answers as my nested if example, just in a slightly nicer way. Now, in that example, I mentioned that we had to write an explicit logical test for every possibility because the ifs function doesn't have a value if false parameter. So just looking at the sequence of logical tests, if h2 is 0, if that evaluates to true, then we get the value of the next argument, not nominated. If the logical test is false, it jumps to the next logical test and repeats the process. So imagine that we got to the end of this, all of our logical tests so far have returned false. We get to the final logical test, and we always expect that to return true. So rather than explicitly testing for that, we can create like a pseudo value if false parameter. Rather than explicitly testing if this is true, if we assume that it always will be, we can replace the logical test with the value true. If that's true, then you get that answer, which is exactly what we'd expect. So just to show that in practice, let's head back to the original worksheet. We can edit the formula there in cell M2, and then rather than explicitly testing for I2 greater than 0, we can enter the value true. So if I just update that formula and then fill the formula downwards, we get exactly the same result as we've just seen, just in a slightly nicer way. It's probably worthwhile mentioning that the ifs function works equally well with text and date values as it does with numeric values. So maybe as another example of that, we could have a column which describes our films according to their genre. So I'm going to check if its genre is science fiction, then it's the best. If it's romance, then it's the worst. And for everything else, it's just, well, anything else. So in column N, I'm going to create a column called genre rating. And then in cell N2, I'm going to say equals ifs. My first logical test is going to check K2 equals science fiction. When you're comparing strings like this, it's not case sensitive, but I'm going to match case anyway. If that's true, then I want to return the word best. Then a comma, and then I can move to the second logical test, which I'm going to check if K2 equals romance. And if so, then that's going to return the value worst. And then for everything else, I want to establish whether it's, I just want to return the value anything else. And I don't want to have to explicitly test for all of the other possible genres. So what we can do again is use that same trick. Using the value true, we can return anything else. We can then close a single set of round brackets, hit enter, and then fill that formula downwards. And anything which is science fiction gets the value best. The single romance film in the list gets the value worst, and everything else gets the value anything else. Just to show that this works equally well with date values, let's create a rating for our films based on their release date. So I'm going to check if the release date was before the year 2000, it's ancient, and then if it's between 2000 and 2010, then it's old, and then for everything else, it's modern. So again, we can just create another ifs function in the next available column. Let's head over to column O. I'll call this one age. And then inside a column, or in cell O2, we'll say equals ifs. And then our first logical test is going to be based on the value of cell C2. If that's less than, and then I need to enter a date value. Again, we're going to have another video that talks about working with dates. But the most reliable way, I think, to enter a date value within a formula is to use the date function. So I'm going to insert the date function, open up some round brackets, and then we can provide a number for the year, month, and day. So in this case, I'm going to check that the year is 2000, the month is number 1, and the day is number 1 as well. So the 1st of January 2000. I'm going to close a set of round brackets for my date function, and then a comma to move on to the value if true for that logical test. So if that's true, then I want to describe the film as ancient, and then a comma, and I can move on to the next logical test. So I'm going to say C2 less than date, and then in some more round brackets, go for 2010, comma 1, comma 1, close the round brackets for the date function, then another comma, and then I can call that sort of film an old film. Then one more comma, and for the final logical test, again, I'm just going to default this using the value true. And then, if that is true, which it has to be, then the film must be modern. I can close the double quotes, close the set of round brackets for the ifs function, and then, as usual, fill that formula downwards to see the various combinations of ages of my films based on their release dates. Now, I mentioned earlier that you can have up to 127 different logical tests in a single ifs function. I think if you do have that many, then you're almost certainly doing things wrong. There are much better solutions, various types of lookup functions that we can use to solve that sort of a problem, and we'll cover those later in this series. But just to show you that you can expand your list of logical tests, we'll create one more example, which is going to categorize our films based on the runtime in minutes. We'll have 4 different possibilities. It's short, medium, long, or epic, according to the runtime. When you're building these slightly longer sequences of logical tests, it can be helpful to draw yourself a little diagram to try to describe to yourself what you're about to do. I think this is probably less important with the ifs function than it would be with nested if functions, but nonetheless, it's worthwhile having a quick idea in your head of what you want to achieve. So here's the basic sequence of logical tests we're going to perform. So each of the blue diamonds is a logical test, and each of the green boxes is the value if true. So that sort of just helps you to understand what it is you're trying to put together. So let's try and do it. Let's head back into the worksheet, and I'm going to head across again to the rightmost column. Let's go for column P, and we'll call this one length. And then in column P, excuse me, sorry, shouldn't have zoomed in there. In column P, cell P2, we'll say equals ifs, and then our first logical test is going to be based on the value in cell D2, and if that's less than 100, then I want the film to be described as short. Then a comma, then D2 less than 150. And if that's true, I'm going to describe that as medium. And then another comma, and then D2 less than 200. Then a comma, then it's long. And then finally, this is the final logical test. So to avoid having to explicitly test if D2 is greater than or equal to 200, I can simply say true, because I'd expect that to be the case anyway, and then provide the word epic. Close one set of round brackets, and then enter that, and fill the formula downwards to see the various possibilities for the film lengths. So there you go, there's how to use the if function, or sorry, the ifs function as a replacement for multiple combinations of nested ifs. Hope you found that one useful. Thanks very much for watching. See you next time.